Hi everyone, welcome to our online lesson 4.1. We're in our new set of notes. This is Unit 2, and we're starting off looking today at square roots and perfect squares. So we're actually going to break our lessons into this lesson into 3 parts, and this is part 1 that we're doing right now, looking at square roots, which is the first square roots and perfect squares. So this is the first part of our notes. Okay, part 2. We'll be looking at perfect cubes and cube roots. And part 3, we're going to look at factored trees or prime factorization. So let's go ahead and get started today. I want to start off by saying in all of these lessons, particularly part 1 and part 2, we're not seeing anything new. So we've already looked, in math, we've already dealt with having to square a number or take the square root of a number. However, what we're looking at today is just getting a bit of a deeper understanding. When I take the square root of something, what does that mean? What am I really doing? And when I square a number, what is that really doing? Because anybody can take the square root of a number or square a number using their calculator. Using your calculator doesn't always guarantee that you understand the mathematical process. So today, what I'd like you to do is just, even if this feels a little bit easy, it's just trying to solidify these concepts for us and make sure that we really understand what it means when I say I square a number or I take the square root of a number. So let's get started. Here's what we're going to look at. We're looking first at a couple of just definitions. We need to know what integers are because we're going to be using these types of numbers called integers in chapter 4. And we're also going to be dealing with some fractions that we can't avoid. And so a couple of definitions around integers and fractions, some math terms we need to know. Then we're going to be looking at perfect squares and square roots. Okay, in part 2 we'll look at cubes. Let's go ahead and get going here. So here's some definitions that we need to know. Integers are whole numbers in the positive and the negative spectrum, as well as 0. So integers are counting numbers. So let's write that down. These are the counting numbers that include the negative counting numbers as well as the positive. So integers, if I put them on a number line, okay, if this is 0, at the center of my number line. The integers are all of the positive counting numbers. Okay, so 1, 2, 3, 4, 5, and on and on and on. Okay, up to infinity, but positive numbers, and also the negative counting numbers. So if I go in the negative direction here, -1, -2, -3, and on and on and on in the negative direction to negative infinity. However, an integer, okay, when I say whole number, what I mean there is a counting number. So 1 is an integer, okay, -1 is an integer. 1.5 is not an integer. So integers cannot be decimals, okay, or fractions. They have to be counting numbers only. So this is a type of discrete data, and a really easy way to remember integers then is anything that you can count where you can't have part, like 1.2, or you can't be in between these divisions. Okay, so all of our integers are only those counting numbers in the positive, the negative, and 0 is also an integer. Okay, now we're kind of come back later to talking about integers. When you see the word integer, we just want to know what it means. All right, so examples of integers there, any of those ones that I put. Okay, so for example, -5 is an integer, 10 is an integer, 0 is an integer, 3, okay, any of those. Not integers then would be, for example, 1/2 or 0.5 written as a decimal. Those are not integers. Okay. 14% would not be an integer because 14% represents 14 out of 100%, okay, which is 0.14, so not an integer. So we've just got to be careful here when we're thinking about them. They have to be whole counting numbers, either in the negative or the positive spectrum, okay, or 0. Fractions. Well, I think everybody knows what a fraction is, but let's talk about the components of a fraction. So a fraction is any number, okay, that's written with something on the top and something on the bottom. So when we look at it, a fraction written, we want to be able to associate the top, which is a, okay, as the numerator. So the number that you have on top, we call that the numerator, and the number on the bottom, it's called the denominator. And we just want to be able to recognize those words and what they mean. Okay, so the numerator is our top number, and the bottom is our denominator. So for example, a fraction could be 4 over 5. Okay, where 4 is my numerator and 5 is my denominator. And the other thing I want to mention here is when we write something as a fraction, which can also be called a ratio, okay, this line, okay, really does mean divide. It's 4 divided by 5, okay, or 4/5. And if I wanted to express my fraction as a decimal, I would simply divide the numerator by the denominator. So 4 divided by 5 will give me a decimal, and that really then means that this line here in my fraction is telling me mathematically to divide. It's 4 over 5. Okay, so let's carry on now and start talking about squares and square roots. Okay, so a perfect square is the product or the number that you get when you multiply one factor by itself. Okay, so one way we can say that is a perfect square is a product. The word product means if you multiply two numbers, the answer is a product. Okay, so this means multiply here. Okay, if I multiply a number by another number, I get a product. That's my answer. And the product of two equal factors. So it's a number or a factor multiplied by itself. Okay, so 5 squared, 5 is my factor, or my number. Okay, and if I square it, it literally means to multiply it by itself. Okay, so 5 squared tells me to take 5. All right, and multiply it again by itself. So 5 times 5 is 25. Okay, now the shortcut here is if we're using our calculator. Clearly we don't need to use a calculator for this one. But in our calculator, this exponent 2, this 2 is called an exponent on the 5. And it's telling me how many times to use the number 5 in a multiplication. Okay, that's what your exponent tells you. This tells me how many times to use, okay, the number 5 okay, in a multiplication. So if that number was, in this case, we're looking at only at squaring numbers. So we're always going to be multiplying them by themselves, okay, once, or just 5 times 5. In other words, I see the 5 twice in my multiplication. However, if this number was something other than a 2, say it was a 5, that tells me 5 to the exponent 5 tells me to use 5, the number 5 times. So 5 times 5 times 5 times 5 times 5. And that will give me a number, okay, which is the product of using that factor 5 times. So when we use a multiplication to find the square of a number, so 5 times 5 gives me 25, this number that I get is called a perfect square. It's perfect because it's exactly equal to 5 times 5, 5 multiplied by itself. 81 is also a perfect square. Well, 81 comes from the number 9 multiplied by itself. So 9 squared tells me to use 9 twice in a multiplication. So it's 9 multiplied by itself, and that gives me 81. And this number here then is called, the product is called a perfect square. Okay, And this is just a little bit of terminology in math. Okay, when you multiply any numbers by any two numbers or any three or four or five numbers, okay, any multiplication, the answer we get is called a product. Okay, if you do a division, the answer that you get is called a quotient. So a little bit of terminology here. So 81 is the product of this multiplication, and it is a perfect square because 9 times itself gives me 81. Okay, square roots then. A square root is a way to undo squaring. So we know that a perfect square is a product of two equal factors. All right, so for example, 5 times 5, two equal factors, gives me 25, which is a perfect square. Okay, one of these factors then is called the square root. So 5, okay, and the factors are going to be the same. So just one of those factors is equal to the square root of 25. So what we're really doing when we take the square root is we're either, you can think of it as undoing squaring, okay, or asking ourselves, what number multiplied by itself gave me that perfect square of 25? Okay, so we're getting back to the original factor that we would have had to use to get to that perfect square. Square roots can be shown in two ways. So the symbol that we generally use for a square root, okay, is this symbol right here. It's called the root symbol. That's the square root, and you'll see that on your calculator. It's the same as this, okay, a square root symbol with a little 2, okay, in the index. That little pocket, right, that's made here is called the index. Okay, so the index is 2. And we generally don't write that 2, okay? This is the general form that we use. Okay, so we usually use this. And that's usually how we see it. But what we need to recognize is when you see that square root symbol, it's asking you what number multiplied by itself twice, okay, will give you the number, the perfect square inside there. Okay, so when we do that, okay, so the square root of a perfect square, okay, will give us just that one factor back. All right, so let's do that. Let's have a look at an example. Okay, so for example, let's do 100, okay? Square root of 100. Okay, what is the square root of 100? Again, you could do that in your calculator. You can hit that square root symbol, put in 100, gives you an answer. But think about what it's really saying. It's asking you, this is a perfect square, okay? So it's saying, well, what number times itself gives you 100? Okay, well, if you go through the numbers in your head, the only number multiplied by itself that gives you 100 is 10. 10 times 10 will give you 100. And so there's the factor, okay, that's being used in the multiplication to give you that perfect square. And so the square root of 100 is equal to just one of those factors, 10. Okay. Another really easy way to think of a square root symbol is 100 could also be written as 10 squared. Okay, so when you take the square root of a perfect square, okay, it quite literally undoes the squaring. Okay, so it's a way of undoing squaring. So it gives us just that one factor back again, 10. Okay, so again, we use this square root symbol, which is a bit simplified because we've just dropped that index of 2. Okay, we've gotten rid of it to represent square rooting. Okay, so we've got an example. Let's change. We've just done 100. Let's do another example here. Let's say, what is the square root of, let's say, 64? Okay, well, square root of 64 tells me to take the number 64 and to square root it, which is really just asking what number multiplied by itself, okay, is going to give me 64. And our answer is 8. 8 multiplied by itself will give me 64. Okay, so my square root of 64 is just 8. It's one of those numbers back. Okay, So I think for most of you, this is something that you've seen multiple times. What I really want to do is just kind of get that deeper understanding of what it's asking you, so that you're not always relying on your calculator. Okay, or if you put something into your calculator, you should be able to check using what you know about squares and square roots to feel confident with the answer that you got from your calculator. Let's just do some other examples that are slightly more difficult, or some examples that involve negative numbers. So on your calculator, because sometimes you do need to use your calculator, particularly if the number is quite large. 6 squared, hopefully you wouldn't have to use a calculator for, but again, you have it there. It's a tool that's there for you to either check your answer or help you if you're stuck. Okay, so when we're squaring a number, okay, on your calculator, you will have a button that either looks like this. Okay, that button means squaring. Okay, or that is a button that can be used to square something. So if you have that button, you would simply put in 6, okay, and then the square button. And you should be getting the answer. Well, 6 times 6 is 36. Okay, of course, you could also just say, if you weren't sure where the button was on your calculator, squaring something is the same as multiplying by itself. So in your calculator, you could also write 6 times 6 equals 36. Okay, and that would work. The other thing, that if you don't have a button like that on your calculator, you might have a button that looks like this. Okay, and it's an exponent button. Okay, or a button like this, y to the x. Okay, these buttons here mean exponents. So when you put in a number, okay, so for example, if I wanted to find the answer to 6 squared, I would put in 6, okay, and if I need to raise it to an exponent, I can put in that little hat key, which means exponent, okay, and then I have to put in a 2 because I'm telling the calculator to raise 6 to the exponent 2, and I'll get 36, okay, or I could hit that button that is a y to the power of x. Okay, 6 is my y value. 2 follows that button. I have to go 6 exponent 2, and it will give me 36. So depending on what your calculator looks like, okay, you just need to figure it out for yourself so that you know which button is your squaring button. Okay, and if you don't have a squaring button like this one, then you just need to figure out where your exponent button is. Okay, finding the square root, again on your calculator, if you're looking for the square root of 49, you will either have a button that it looks exactly like that, it's a square root button. Okay, and if you have that, then you're simply going to either hit the square root button first, okay, and then you're going to put in 49. Okay, so you're going to tell your calculator to take the square root of 49, and it should come out to be 7. Okay, you might have to do that in a different order. Some calculators prefer to have the 49 first and then the square root symbol. Okay, if you don't have a button like that, you might have a button. Most people do, and if it's not on their calculator, it's sometimes written above another button. Okay, so you can come and talk to me if you aren't able to find what that button is, where that button is on your calculator. Okay. So let's do a few examples. Again, now we're going to deal with some fractions as well as some integers here. Okay, so express your answer as an integer or as a fraction. And a fraction will be, if it's written as a fraction already, we'll keep it as a fraction. So 8 squared, well, 8 is an integer, so our answer here will be an integer as well. So 8 squared is equal to, well, 8 times 8. Okay, and if you want to just practice with your calculator, make sure you're using it correctly. That'll be 8 squared, or 8 exponent 2, and so we get 64 as our answer for that. If I have negative 8 squared, okay, when I square a negative number, I always get a positive answer because negative 8 multiplied by itself, okay, negative 8 times negative 8 is going to give me 64. And it will not be a negative 64 because a negative number, okay, times a negative always gives me a positive. Okay, I like to think of those two negative numbers. Okay, one negative, The other negative here, if you were to rotate that 90 degrees and put it on top, it actually creates a plus sign. That's one way to think about that. Okay, so the two negatives make a cross, or they make a positive. And so always when you have a negative number squared, it's going to give you a positive product. Be careful that that negative sign is inside the brackets. When a negative sign is inside the brackets, it tells me to use the negative number in my multiplication. Okay, let's compare that to the question below, which is negative 8 squared. Okay, there's no brackets here. If there are no brackets around that, okay, what it's telling me to do is only square the 8. Okay, that negative sign, if there's no brackets, that negative sign stays out front. Okay, so what I have is a negative product. So 8 times 8 is going to be what I'm squaring. So I'm only squaring the factor that is directly attached to my exponent. So that 2 is only on the 8, okay, because there's no brackets around it. So my answer is going to come out to 8 squared is 64, but I have to carry that negative sign in the front. Okay, so please be careful. There's a big difference if there's brackets or not. 154 squared, okay, again, this is equal to 154 multiplied by itself, 154 times 154. Using your calculator, okay, you could square that using your calculator, and we get 23,716 as our answer. Okay, here's the bottom one here is a fraction. This is, let me rewrite it like this. This is 3 over 4 in brackets, all squared. So it's telling me to use the fraction 3/4 in a multiplication twice. In other words, 3/4 multiplied by itself. Okay, so what I have here is I'm multiplying fractions. This is the same as 3 squared over 4 squared, or 3 times 3 over 4 times 4. We're going to do a little review of fractions a bit later, but when you multiply fractions, you multiply the tops and you multiply the bottoms. Okay, this is different from adding. When you add fractions, you have to have a common denominator, but when you're multiplying, you multiply right through on the top and right through on the bottom. Okay, so our answer is going to come out to be 3 times 3 is 3 squared, which is 9. 4 times 4 is 16. Okay, so I get 9 over 16, and there's my final answer. Okay, if you can reduce your answer, you do. If you can reduce it to a smaller fraction, but in this case, we can't, so we leave it at 9 over 16. All right, let's go ahead and do some examples of square roots. We're almost done. So examples of square roots: express your answer as an integer or a fraction. So again, an integer if our question involves an integer or fraction. Okay, sorry, let me fix. Just going to fix the second one for you. Okay, unfortunately my square root symbol doesn't go all the way. I only want that square root symbol over the 100. Okay, and then the second one. Okay, and in the third one, let's take that square root symbol and put it over the whole set of brackets. Okay, and on the bottom one as well, I want that square root symbol right over the whole thing. Okay. Okay, let's solve some of these problems. So when I take the square root of a perfect square, I'm going to get the number that's been used in that multiplication to give me the perfect square. So 64 is the same as 8 squared. So when I square root 64, my answer is going to be 8, positive 8. Okay, and we can actually in math say, truly, that could be plus or minus 8, because it's true that positive 8 times positive 8 gives me 64. It's also true that negative 8 times negative 8 would also give me 64. So there's two possible options here. Plus or minus 8 is an exact way to write my answer. Okay. Let's do the next one. We have the square root of 100 over 2. So that can be written like this as well. Okay, square root of 100 divided by 2. If my square root sign is only over the 100, the number 100. I'm not going to square root the 2, only the top. So only the numerator is being squared. And let's think about that. Well, 100 is 10 squared. It's a perfect square. Okay, divided by 2. So if I were to undo the squaring or say what number gives me 100 when multiplied by itself, the answer is 10. So square root of 100 is 10 divided by 2, which I can actually simplify. 10 over 2, or 10 divided by 2, gives me the integer 5. There's my final answer. And truly, I can come back here and say that this should be plus or minus 10. And so my answer is plus or minus 5. Okay. The next question here could be written like this as well. Okay, inside my square root symbol, I have 100 over 4. Okay, so that whole number was in brackets, which tells me I'm square rooting all of it. So again, it's the same as square rooting the top and square rooting the bottom. Okay, so I asked myself, well, what is the square root of 100? It's 10, plus or minus 10. Okay, and the square root of 4 is 2. 2 times 2 gives me 4. And again, so my answer here again is plus or minus 5, because 10 divided by 2 is 5. Okay, last question here. This is a great one because it involves a variable, x. This is called a variable. A variable is a letter that we use to represent a number that we don't know. So we're not sure what x is, so we call it x, okay? And when you see x squared, okay, that's just like a number squared. It's saying that you have inside here, okay, that is 16, okay, times x again. Okay, so x squared, little side note here, is just equal to x multiplied by itself. Okay, x used twice in a multiplication. So again here, I can think to myself, what's the square root of 16? Well, it is equal to 4, plus or minus 4. Okay, that's the factor that multiplied by itself gives me the perfect square 16. And the square root of x squared is going to simply just be x, because x multiplied by itself gives me x squared. So my answer here is plus or minus 4x. We'll deal more and more with square rooting variables, okay, a little bit later on in this course. Great. Finally, I'm going to do one more example with you, and it's this one here. Okay, if you had a negative sign out front, okay, so let's say inside you have, let's just do something easy like 9. Okay, if the negative sign is out front, you keep it out front. Okay, so we have whatever our answer is here. Okay, a square root of 9 is going to be 3. Okay, I'm going to have my answer reported as a negative here. Okay, for now. Now it could be, truly it could be plus or minus 3. Okay, and it's fine to leave it just like that, and we can also say negative 3 here. Okay, for our purposes in Math 10, that's fine as well. If you have that negative sign out front, it has to stay out front. Okay, and then finally I want to say one more last note, and that is that you cannot take the root, okay, the square root, okay, of a negative number. So it is not possible to take the square root of negative 9. Okay, there's no solution to this. We don't deal at all actually with this in Math 10, but if you go on to take Math 11, it is important that you know that. You can't, there's no factor multiplied by itself that will give me a negative 9, okay? Because a negative 3 times by itself gives me a positive 9, and so does a positive 3 multiplied by itself. So there's no combination of two equal factors that would give me a negative product. So that's just for you to know for future. At this point, you can stop, and I'd like you to try some questions on your worksheet. So you have a 4.1 worksheet, and on the first page of your worksheet, okay, you can do any square. So any number there that's being squared, you can now go ahead and solve that. And on the second page, okay, you can do the section called square roots. And you should be trying all of those and checking your answers. See how you're doing with it. Okay, so good luck. Thanks for joining me, and I'll see you for part 2.